Yes, hello. My name is Johannes. I'm also part of this OK Lab Berlin, and I'm happy to be here in this big blue button instance of our friends in Ulm. Yes, there are my slides. Great. Um, yes, Jochen? No, I cannot change the slide. Now I can change the slide. Yes. Okay, great. So I'm going to speak about pd3f, Beyond PDF. It's a tool I've been working on for 6 months. It has been funded by the Prototype Fund, a program by the German government to fund some open source projects. So this work is sponsored by the Federal Ministry of Education and Research. And I have to say this every time I'm going to speak about this project. So let's get started. What it's about. I built a full pipeline to process PDF and to extract good continuous text. And I want to give you some reasons why this is important. Why are you interested, or why am I interested in extracting this kind of continuous text? So when you work with some digital PDFs or some scanned PDFs, you may just want to have like this text. And with German, I mainly work with German PDFs. You got the problem that that the long compound nouns, they get split. So near the line end, usually there are hyphens there, and you cannot just get the continuous text out of it. And this is why what I like the broader task of what I did over the past 6 months. And some use cases. Okay, why is it important to have like continuous text? So the one very useful thing is to search documents. And if you want to search for specific words and those words got split on a new line end, you are not able to find them. So this is important for journalistic work that work with leaked documents and so on. It's important that those words that got split get found anyhow. Then it's also important because sometimes journalists, they have some documents, but they cannot share the documents because there are watermarks hidden inside of PDFs. Sometimes they are visual, but sometimes they are also not visual, like printed dots on sheets of paper that then got scanned. So those news organizations cannot just publish those PDFs online. This happened with the Intercept. They fucked up one story, and Reality Winner, like the source, she got jailed because there were hidden watermarks in the PDF. So those people, they should not just publish the document, but just the text. And then this text is also useful if you want to process those documents further with, for example, machine learning or artificial intelligence. And what is very interesting with those documents is this idea of named entity recognition. So to automatically find persons, organizations, and so on. And those machine learning tools, they only work with continuous text. If you just fill them with some scrambled PDF output text, they don't work so well. So those are the reasons why it's important to extract continuous text. Yeah, myself, my name is Johannes Filter. I studied computer science for 8 years, and I have a master's degree. And I always did some NLP, natural language processing, and machine learning. But on the side, I also had this journalistic job at an organization called Frag den Staat. They are working with the German Freedom of Information Act that basically gives you right to access documents. So you can write to the government, please send me this document, and then the government responds with some documents. But mostly they respond with print out documents, and then you have to scan them. So, and I thought, okay, maybe we can somehow work on those documents, because I'm very annoyed by this corrupted, scrambled text of PDF. And so, yeah, this whole idea of the tool was born. And now I just want to speak briefly about the PDF, the portable document format. It has been developed by Adobe in the 90s, and it's a super complex format. So I got this reference, and it's over 1,000 pages long, and basically you can do almost everything with PDF. They are so universal, and that's also the reason why PDF is so popular. And if you speak about documents, and especially scanned documents, mostly you speak about PDFs. But this PDF format is very tricky. It's very old school, let's say it like this. Just one example with text. So the text in those PDF documents, for example, with scanned documents, sometimes there are only letters at a certain position. Sorry. So for example, you got this text, and then in the PDF there is written, okay, the T is at position X and Y, and the E is at position X and Y, and the X and the T, and so on. So this, in the first steps, it just shows you how hard it is to just extract some basic text, because the tools have to really combine those letters, and they work with heuristics to give you some kind of text if you want to copy the text, for example, out of a PDF. And yeah, then you have this two kinds of PDFs basically. So I'm working mainly with scanned documents. So documents you get sent by mail, and then you have to digitize them, and you there is no text at all. And then there's those digital PDFs I call, that are, for example, exported by Microsoft Word and so on. And it's easier to work with those documents. But yeah, sometimes you don't have them, and so for my work I choose to work with this with a picture version of PDFs, because then I can, if my tool, if it works fine, then it can process both kinds of PDFs. So it can process digital PDFs and also analog. So basically, right now I just ignore the digital PDFs and just consider them also as image-based PDFs. So yeah, as a first step, we have to really find text in images. It's called OCR, optical capture recognition, and this has been solved more or less. So you get an image, and then for humans it's fine, we can read it. But to make it like searchable and so on, you add invisible text onto the PDF, and then you got this OCR PDF, and I just use this tool. It's called Tesseract. It's pretty old school. It has been around since the 80s. And it works fine, but if you just want to use it to work with PDFs, it's not so easy, because you first have to convert your PDF into an image format and so on and so on. So I used another tool, and I also recommend it. It's called OCR My PDF. This uses Tesseract internally, but this also enhances the images. So for example, when you have a document and you use an ordinary scanner, it's very likely that the image is skewed. And so this tool does some kind of pre-processing to really make sure to align the document again. And this really helps with the output quality of the OCR. And here I want to speak briefly about this idea of language model and machine learning. About machine learning, because Tesseract uses some kind of machine learning. The newer version, Tesseract 4, it uses language models to improve the output of OCR. So language models are just, they are very famous right now. One very famous one is called GPT-3. And the idea of those language models is that they can predict the next word, for example. So if we give them the example phrase, "Can you please come?" the next word should, for example, be here. And this can, and those language models, they get trained just on random text. And right now, you have a lot of random text all over the internet and in books and so on. So you can use machine learning and just throw a lot of text at those machine learning models. And then the language model is like quite good. And this can be used for OCR, and Tesseract does it because it can predict the likelihood of a word if it's on a paper. So I just wanted to throw it in. This is not what I did myself, but this Tesseract also used some kind of machine learning to find text and images. So yeah, so now I just added text to PDF, and now I process it further with another program. It's also not by me. It's called Parser. It's from the French insurance company AXA, and they started it in August 2019. So very late, very recent. And when I wrote the proposal of my work, this was not done, and I'm super happy that this AXA company worked on this project, because it really helped me to bring structure into documents. And I just show you at one example what it does. So the idea is that they include several other tools to process PDF, and what they do is they split up the text in PDFs into paragraphs. And this is super helpful to extract continuous text, because the first, so at first you got the word, then you got line, but then you are interested in actually paragraphs. And this tool solves this somewhat. So on the right, you see, okay, this is like solved like very, very nicely. But on the left, you also see that it didn't really capture the paragraphs. So this tool is very dependent on certain parameters. So if you want to try it out, you really sometimes have to tune it to choose some parameters. But generally, it's a very, very nice tool, and especially useful for my work. So yeah, it's part of my pipeline. So yeah, now comes the part that I actually worked on, that I developed, and this is about this continuous text extraction. So coming back to this is the problem, that you have this strange hyphens in Word, and you just want to join the lines again, and you have to check, okay, can I remove the hyphen or can I not remove it? Because there are, now I want to speak briefly. Yeah, because I already mentioned this, sometimes it's only character-based. And to decide to decide if I can remove a hyphen or not, I'm using also language models, like these language models I spoke briefly about before. But now I use some other language models. And those language models, they predict characters. So if you simplify those language models, there are 26 characters in the alphabet. And then you also feed in text. And it's really about, okay, just predicting the next character. And this is super helpful in this case. So this is in German. This is a German sentence. 2 German lines, and they are split. There's a hyphen in the end of the line here. And so what I do, what I introduce, this method is, okay, there are 3 different types. How can those 2 lines be joined? And those are my 3 candidates. And then, this is the first one. This is just, okay, I add a proper space between the hyphen. And basically just add a space after the hyphen. Then it's like, okay, no, we don't want to add any space. It's just like this. And then the third option is, okay, I can remove the hyphen and then just concatenate those two words. And what I do with those language models is that I can get a score, the perplexity score, it's just called. And this is the score says how likely is that those words are part of the German language. And yeah, if you're able to speak German, you can also say for sure that the last word is like part of the German language, whereas the other words here, they are not part of the German language. And here I have to say that, yeah, I just wrote them some pseudocode, and normally you would join them to add a space, or no, you just concatenate. So yeah, maybe I should have, yeah, just think those two are one word. So yeah, here it also says, okay, yeah, you are able to remove the hyphen, and then you can just join, and it's fine. Yeah, and maybe you think, yeah, but in 95% of the cases, you can actually remove the hyphen, and it will work, and that's true. But there are sometimes also situations when you cannot remove it. For example, in this case, where the hyphen is part of the word. And here you got those three candidates. And here, if you would remove the hyphen, this word would not be part of the German language. It doesn't make any sense. And so this is like the candidate that gets chosen by my tool. Yeah, so my tool is a Python package that can be used without using any kind of PDFs. You can just insert some text, some words, and then they decide, okay, can I join the words or can I not join the words? And yeah, you can try it out. So what my tool, for my tool, I wanted to do more because I really think this idea of having these documents in this PDF format that's meant for printing, it's not the way how it should be, because here you got the case that the continuous text is split because there is a page break, and you got some footnotes here. So what my tool does is also to first check, okay, those are like footnotes. You can basically just ignore them; they are not part of this text. And then my tool checks if what is more likely, that that this paragraph is also part of this paragraph, as with this example, or not. Yeah, but this is very experimental. So if you use my tool, this is not the default configuration, because especially detecting, for example, footnotes sometimes gets really tricky. And also, like, for example, this page numbering, or here you got this header, and so on. You can try it out. I have a demo running where you can just upload some PDF and it gets processed. And there's also an API. So, and this is meant, for internal use cases where you have to process some PDFs automatically to do all kind of text stuff. So yeah, this is the end of my talk. Thanks for your attention, and I'm happy to answer questions or also discuss certain things. I can also speak more about more option. Okay, there's one question by Edgar. Yeah, maybe I can speak more about this language model that I use. I use Flair. I'm not sure. Maybe I have forgotten. Yeah, this is this. Flair is developed by Zalando, like this German shopping, I don't know, platform. They also do crazy machine learning stuff, or they used to do it. They got also some research grant by the European Union, and they developed, they have this framework, and they are really good with detecting named entity recognition. And they do all kinds of stuff, but I don't use all the other functionalities. I just use the language models. And they are character-based. that also means that fit this use case, because I'm working on characters, but this also means that it's very consuming, like process. You need a lot of compute to use it, other than other language models. But they have a lot of different pre-trained language models for all kinds of languages. And so I just use them. And yeah, I think you could, it's very easy to replace them with another character-based language models. I mean, you could also maybe do it with some, there are, I'm not sure if we want to go into, but there are different kind of language models that work on subtokens, so not on characters, but more like 3 characters at a time and so on. And you can also maybe try it out, but yeah, this is like really research, and I think a researcher has to look into this because I don't have time for it, unfortunately. Yeah. Yeah, this is also like evaluating. This is a good point because so far I only did basically manual annotation. So I looked at like 20 documents and I decided myself, okay, this is how the text should look like. And I just validated with those 20 documents. And I want to do more evaluation about it. And one method, I also thought about it. And one would also to use some other kind of language models and just check the perplexity of the whole text. But of course, this is not, this is like not really well tested software, let's say. It's very experimental. I think one has to look more into this to really see, okay, is it better or not? But I think it's still better than what it's been done before, because before in Germany, we got a lot of projects that work with PDFs and we really just extracted like this text and it was all scrambled. And now I think it's still better than it was before. Yes, I also used at the law, I looked at a lot of PDF tools. I also have like a complete review that I'm going to post here. And as a first step, they use PDF Miner. So it's part of this parser library. And I also think that PDF Miner is currently the best way how to extract text. And I also spoke with some other people that also really into this PDF Miner thing because it's also maintained. Because with this PDF processing and Python, there are a lot of unmaintained software. There's a lot of unmaintained software, but this is working fine. Oh, multiple people are typing. Yeah. Yeah, it's super hard to say, but it really depends on your PDF and also your compute. But I think like, I don't know, 20 seconds per page. So it's quite long. And I also, I think, and initially I thought it takes so long because of all the machine learning part. But then I realized that this parser library that's not doing any kind of machine learning, it's super slow. And I think this really can get improved at some point. I think really it does not have to be so slow. I think it can be super fast. But the problem with all those tools is that there are not many people working on it, and then you basically don't care. It's cheaper just to get a bigger machine and just run it with some bigger computer than software developers really tune this for performance. So generally I think performance is still a lot important to work on. Yeah, have you looked at more? Yes, multi-columns are working sometimes. So this I didn't really make it work with multi-columns, but right now this parser library, they say that they can detect columns, and it's also working. But yeah, it's tricky. It's not working out of the box for some cases. So, but I think if you have some column PDF, that I would try it out. Yeah, it's better than nothing. But yeah, those tools are pretty new, and I hope they will get improved at some point. Yeah, and also there are some Python libraries that extract tables. One is Tabula, and another one is called Camelot. And this parser library they included both, so you also get the output of this table detection tools. And yeah, it's working. I mean, but it's like with all those tools, it's working in, I don't know, 50 or 60% of the cases. So it's not working 100% so far. Um, Yeah. So and yeah, just to answer the last question by Vasgat. So yeah, the first step, I process the images and put text into it, OCR. With OCR, my PDF, the tool. Okay, some more questions. I have time. Yeah, this what's up on the roadmap? Good question. So the funding is over, and unfortunately, I have a lot of work to do right now. But I will continue to continue to work on this project, and some stuff that's really uncool right now is that I have Docker images. You can just use this Docker image to also run it on your computer, but you need 4 GB of space, and that's not really, it's not really reasonable. And also, you don't need those 4 GB. You could make it in 1 GB, I think, or 2 GB. So the next thing I want to work is really like to remove like unnecessary stuff that got in from dependencies that install really huge software libraries that are not really used. So I think this is the next step. And really, I think I also want to do more of an evaluation and also see, okay, how good is it really, and so on. Yes, and it's all open source. Maybe I just open the last slide again. Jochen. Yes, I have 3 examples on my website. I will also link it. Yeah, I just have a link. I mean, I could share my screen. I'm not sure if this is useful. But yeah, the one PDF is really what I also had in the beginning. Yeah, and basically what I work with letters. So this is also maybe important to note, because I personally had to deal with a lot of German letters because of this Frag den Staat thing. So my main use case to really German letters and some simple documents. And I think it's also easier at this kind of domain because the documents are very boring. So they are not fancy, it's just text, black text on a white background. I think if you're really into this corporate document, if you have like flyers and so on, I think it also gets more complicated. All these reports that corporates produce, I think it's also complex. But yeah, I still think this PDF domain is a great area to work with machine learning, because are created by humans, and all PDF documents, a lot of documents are there's no standards, you know. You cannot just write, yeah, the footer is 5 centimeters from the top and so on. So I think it's really a great area for machine learning. Oh yeah, there's one, Volker. Also gave a link. Yeah, and if you are really, maybe I can also link more. If you are, for example, really into table extraction, there are also some super machine learning tools that only deal with table extraction. But I don't use them right now. But maybe this could also be useful to integrate to really make this table extraction better.